Let's look into histogram. An important note that it has to be used in continuous class interval. If it's not continuous, then you have to convert the data into continuous. How do you do that? I have a separate video on that. It's supposed to be one of the previous videos. You have to watch that and come over here. So you will be doing it as well. We'll be having an example wherein the data is not continuous and we convert it to continuous. But again, having the basics is better than just looking into a problem then learning it over there, right? So few basic characteristics of histogram is that along the x-axis we take in the class intervals, along the y-axis we take in the frequency. The height of the bar depends on the frequency, so we'll be looking into this. The product of the class width and the frequency should match the area of the bar. We'll discuss this later with another example. The procedure is make the class continuous. So let's start off with an example, because reading something won't help, right? So let's start off with an example. Now, is this class continuous? To check that out, we need to look at the upper limit and the lower limit. Here the upper limit is 35.5, 40.5, 55.5, so on and so forth. And the lower limits are 30.5, 35.5, so on and so forth. If the upper limit and the lower limit are linked, that is, if they have the same values, then it is said to be continuous. If it's not continuous, what should you do? That we'll be learning in time. So this is said to be continuous. Next thing is modify the length of the rectangle if the class size is varying. So how do you check the class size? Subtract the upper limit and the lower limit in each of this class. So the difference is 5 over here, 5 again, 5 again, 5 again, 5 again, and 5 again. So all of this, the difference is 5. Decide on the width of the bar. So the width is, width of the bar depends on this set of values, the number of values, and also the space I have. For that, we need to look at the graph. So this is a graph sheet. Let's say I draw it over here. And over there. And we have, now. So let's look at it. So we have 30.5 to 60.5. If I go with 10, 20, 30, 40, that will be too close because we have 35.5 and all of that. What should I do? Well, if I go with, if I try to expand it as 0, 5, 10, 15, that will be too much. Actually, we can go between the intermediate way. That is using something called as a kink. Kink helps us to compress the line from 0 to 30.5. We can directly jump in between. Since there's no data, it's gone. So this heart shaped thing is telling that the line from 0 to 30.5 is compressed. Okay, so this heart beat shaped structure line is telling that we have compressed from 0 to 30.5. And then we have 35.5, 40.5, 45.5, 50, 55, and 60. This is 35.5, 40.5, 45, 50, 55, and 60.5. Next is the number of students. So here we have from 1 to 15. So if I go with 1 to 15 over here, I don't want to experiment since there is only few set of values. So I'll just go with 2, 6, 8, 10, 12, 14, and 16. This will look decent enough. Won't be an issue. So this we decided on the scales. and y-axis scale also we decided. Then draw the data. So data, we have 30.5 to 35.5 is 9. So that will be 9. And 35.5 to 40.5 is 6. Then the next value is 15. So it's still over till this point. Then the next value is 3. 3 will be over here. Oh wait, my bad, I made a mistake. I missed 4 itself. This whole thing is wrong then. But I won't erase this because I can do this. First value is 9, right? So 9 will come over here. Then 6 is still here. Then 15 is still here. Then 3 is still here. And 1. And 2. Right? So this is your x and y axis. And that's your set of data and representation. Label the axis. Okay, I didn't do that. Let's do that. We do the data. Now let's label the axis. So we have mass, that is in kg, along the x-axis, and this is number of students along the y-axis. We labeled things. Right about the scale. Now here we have taken scale along the x-axis for every centimeter. What is that we are looking at? For every centimeter we are looking at, or every 2 centimeter we are looking at 5 kg. And y-axis, for every centimeter we are looking at 2 students. That's it. So this is your histogram. So people who are interested in writing down procedure, you can write. And this is a bit about your histogram. It's mainly about how to handle when you have a bit of variation, that I'll be showing. How to handle a discontinuous table, how to handle class width, varying class width. So that is the one which is a bit tricky. If not, this is quite simple. Okay, so this is your end product. All this is good, but it's kind of tedious, right? What if you have huge data? Can we kind of program this? Actually, we can. So this is a program which helps you guys take the data from Excel sheet and put it across depending on what class size you guys want. So why is this class size being asked? I'll be discussing this in the next problem, but I'll show you guys that here we took class size of 5 and that's your output. Let me show it to you side by side. Can you see this? That's your output. So we have values, that is mass and so on and so forth. This is your frequency, and that's okay. Title we are not put. Title over here. And we can see a similar structure, right? Okay. So yes, we can code it, and we do get the same answer or similar answer. So have a look at what and all is possible. Keep this in mind so that you get, whenever you want, you get to use it. We are not just trying to know, okay, this is how you get a histogram from by coding. It's not only that. It helps to know, okay, this is possible out there. There's so many possibilities. What suits your agenda, you use that. So you need to understand that knowing that there is something like this is also important. It's okay if you don't know, you don't get to know how to code this. That's absolutely okay. But knowing that, such a possibility is there, learning that is also important. Even that counts. Okay. So that is also part of my agenda exposing you guys to possibilities.